What I have for you today is a very simple DC power supply, if we're going to call it that. Um, I have some KBP C5010 rectifier diodes I got from a Chinese supplier, so they look legit. But a nice high current rectifier, 1000 volt, 50 amp, I think was the rating, which sounds ridiculous. Let's see what this was. Is it? Yeah, it claims 50 amp current, 1000 up to 1000 volt. But a couple of those guys. So what I'm going to do is I'm going to show you what this looks like when we look at it through an oscilloscope. I have a DC power supply, a DC load bank, and then I have a capacitor I will add and remove in the circuit to kind of show what's going on. So let's start by switching over here to the oscilloscope. All right, we're going to see if this works. I'm going to turn on the AC power supply. And I'll start increasing the power. So there's no capacitor on the circuit right now. You're at 20 volts per division. Okay. So you see all the ripple there. Very noisy. And if I look up, see frequency is not entirely accurate there. Very noisy. The frequency counter's having trouble getting that. So I'm going to plug in the capacitor. I want you to watch what happens when I connect this 350 volt DC 1400 microfarad cap. Bam. Disconnect it. Connect it. So completely smooths things out having capacitor hooked in parallel with the DC output, right? So it's acting as a good primary filter cap there. I'm going to energize our DC load bank. And you're going to see a little bit of ripple once this fires up here. Increase the current draw. A little more. A little more. And let's get a little bit more current. There we go. There we go. Let's drag it down some. So you can see, there you go. Eventually it breaks and I start getting this really bad ripple. But that ripple is what you expect. So as I decrease the current, you see the ripple almost goes away. Let's see if I get this down to, that's about an amp. Let me turn this down some. Right at 1 amp, 24 volts. And you can see the ripples definitely there. So if I change there you go. Hopefully that comes through on the, but you can really see that ripple. And so the reason you're seeing that though is it's, rectifier is putting out the peaks. So it's inverting the lower peak and putting out the upper peak. So you're getting basically double frequency, right? So 60 times 2 there. And if you look up, you've got a frequency output here that's roughly saying 120 hertz. So if I unplug the cap, this is going to be the fun part. It's going to get wild pretty quick. I'm going to disconnect Mr. Cap here. It's really hard one-handed. The case with almost every experiment I keep doing. It's it's just like a real pain to try to do this with one hand. Hold on. I want to pause this for a second. Just take the lead off the capacitor. There we go. All right, look at that. And that is an absolute mess. Let's speed this up a little bit so you can see. All right, so you see that? That is disgusting. So we've got no cap anymore, and we have load. And you can see that we're really swinging around there. That's like a delta of 30-ish volts. Connect the cap back up. And you can instantly see a change by having the capacitor connected, right? So if I decrease the voltage, the current's going to stay there. But you can see eventually I'm going to get to a point here where get right. Let's zoom in just a bit here. There we go. Right. Okay, and then we will alter our load just a little bit. Keep dragging it down. Let's see here if I get it to, oop, there we go. So you can see that pattern is just garbage once I get it really loaded down. If I heavily load it, that's a terrible noise.
So we're really getting some nasty waveform there. So that's not good for anything. I want to turn that down. My 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 DC load is not enjoying that particular waveform. Making some pretty gross noises, but you get the point. So um, that is the effect of a smoothing capacitor on a rectifier. Well, hope you enjoyed that.